In the last lecture, we stated that a covalent bond is a pair of electrons shared between two atoms. With that information, we can now think about the quality of these bonds. One very important question to ask is, are the electrons shared equally, and why or why not? In fact, this is probably the most important question to ask in biology, as it leads us to the most important concept in biology, in my opinion, electronegativity. With the concept of electronegativity, we can explain the mechanisms of virtually everything that occurs in viruses, bacteria, molds, plants, animals, and all living things. Whether the electrons of a covalent bond are shared equally depends on the two atoms' relative electronegativities, that is, their ability to draw electrons to themselves. So let's look at covalent bonds between different atoms and ask the question, are the electrons shared equally? First, consider a covalent bond between two carbon atoms. All atoms of carbon have the same electronegativity, so the electrons will be shared equally between the two carbon atoms. Now, we'd like a concise synonym for electrons shared equally. Nonpolar is the word we'll use because as we look at the bond, there is no place that a pole of electrons, a location where we have an overabundance or an absence of electrons, exists. So instead of referring to such a bond as a covalent bond in which electrons are shared equally, we refer to it as a nonpolar covalent bond. Now let's imagine a covalent bond between carbon and oxygen. To determine if the electrons are shared equally or not, we need to know the relative electronegativities of carbon and oxygen. It turns out that oxygen has a much greater electronegativity than does carbon. So I've got a few questions for you. Are the electrons in the carbon to oxygen covalent bond shared equally? Well, if you answered no, you're correct. The electrons are going to spend more time around one of the two atoms. Thus, we refer to the bond as a polar covalent bond. 2. Which of the two electrons will hold the electrons for a greater period of time, carbon or oxygen? Now remember, oxygen is more electronegative than carbon. And so the answer is that oxygen will hold the electrons for a greater period of time. It has a greater electronegativity, or ability to draw electrons to itself. Now the atoms carbon and oxygen have not lost or gained electrons. They have access to both electrons in the covalent bond, so they don't have formal charges, positive or negative, but they do behave for part of the time as if they are charged. Thus, we say that the atoms have partial charges. These result entirely because of the electronegativity difference between oxygen and carbon. 3. Which one of the atoms do you believe would have a partial negative charge? Now remember, oxygen is more electronegative than is carbon, so the answer is oxygen. 4. How would you describe the condition, specifically the electrostatic condition, of the carbon in this bond? And if you said partially positive, well done, you're correct. Now let's consider a covalent bond between carbon and hydrogen. Now, this is a little bit tricky. While the electronegativity of carbon is greater than that of hydrogen, they are similar enough that a carbon to hydrogen covalent bond behaves as if the electrons are shared equally. That is, the carbon to hydrogen covalent bonds can be considered nonpolar. Neither the carbon or the hydrogen has a significant partial charge. Now we can take the terms nonpolar, having an equal distribution of electrons, and polar, having an unequal distribution of electrons, and apply them to molecules. Here is ethane. It contains only carbon and hydrogen. All of the bonds are nonpolar. The distribution of electrons in the bonds is equal, and thus the electrons are equally spread over the entire molecule. There are no poles. There are no places where electrons are overabundant or lacking, so we say that the molecule is nonpolar. Note, there are no partial charges. All atoms are neutrally charged. Ethanol is very similar to ethane, but we've added an oxygen in. Ethanol has a carbon to oxygen covalent bond and an oxygen to hydrogen covalent bond. The electronegativity of oxygen is significantly greater than either carbon or hydrogen. Thus, Oxygen is holding on to those electrons for a greater period of time than is either carbon or hydrogen. So, how would you describe the nature of oxygen? The answer is partially negative, and the carbon and hydrogen would both have partial positive charges. The unequal distribution of electrons makes ethanol a polar molecule. So is every molecule that has atoms of different electronegativities a polar molecule? Surprisingly, the answer is no. Here's one notable exception, definitely one that you should be aware of. Carbon dioxide is a very important molecule for us to consider. Its chemical formula is CO2. Its carbon is bound to two oxygens, which are withdrawing electrons from carbon. But CO2 behaves as if it is a nonpolar molecule. So why is it nonpolar? The answer is that the bonds make the 3D shape of carbon dioxide flat or planar. Thus, over the whole molecule, the electrons are shared equally. This is tricky, but a great example that structure determines function. In this lecture, we've looked at small molecules and learned to determine if they are polar or nonpolar. We've also learned to assign partial charges to atoms in polar molecules. In the next lecture, we'll ask the question if the partial charges of different molecules can interact with each other. Thank you very much for watching. I hope this was valuable. See you in the next one.